Today we will attempt to solve the A-Level H2 Mathematics 2015 Paper 2 Question 9. This is the second video of a series of 3 where we look at some past year questions that require us to find greatest and least probabilities. So let's start with a brief overview of this video series. We are currently in video 2 where we will mainly be looking at the 2015 Paper 2 Question 9. To solve this question, we will be using a Venn diagram, trying to fill it up, and using algebra if necessary. This method was actually covered in the first video where we introduced this approach and use it to look at an example as well as the 2010 Paper 2 Question 8 Part 5. The 2010 question is actually very similar to the 2015 question. So if you are struggling with the 2015 question and have not looked at video 1, I do recommend you take a look at it and see if the method described in the video can be useful to help you solve the question. Before we proceed to attempt the 2015 question, we will also do a quick review of some of the formulas required in this question. They include the conditional probability formula as well as the formula for independent events. So this covers the second video, and in the third video, we will take a look at yet another question in the TOIS that asks us to determine greatest and least probabilities, the 2018 Paper 2 Question 7. So let us review some of the formulas we will need. The first formula is the formula for conditional probability. The probability of B given A is given by the probability of B intersect A over the probability of A. Meanwhile, when we are told two events are independent, we have the formula that the probability of A intersect B is given by PA multiplied by PB. These are two other equivalent formulations of the concept of independence, but for this video, we will focus on this first one over here. So with that, let's take a look at the 2015 question. So the question goes this way. For events A, B, and C, it's given that the probability of A is 0.45, PB is 0.4, PC is 0.3, and PA intersect B intersect C is 0.1. It's also given that the events A and B are independent, and that events A and C are independent. For part 1 of the question, which is worth 1 mark, we were asked to find the probability of B given A, the conditional probability. So we have just reviewed the formula, so let's apply it. So the solution goes this way. The probability of B given A is given by the formula PB intersect A over PA. We are also told that A and B are independent. So PB intersect A is given by the formula PB times PA. Now PA will cancel, leaving us with just PB, which is 0.4 as given by the question. So the answer for part 1 of the question is 0.4. Next, we will attempt part 2 of the question. So part 2, we are told that events B and C are independent, and we want to find the probability of A prime intersect B prime intersect C prime. So part 2 is worth 3 marks, and it is quite a lot tougher than part 1. In particular, there are 3 events that we are working with, and we don't have a nice formula for A prime intersect B prime intersect C prime. Hence, let's try to use a Venn diagram and slowly fill it in. So in the first paragraph of this question, we are given the values of PA, PB, PC, and PA intersect B intersect C. We are also told that A and B are independent, so this allows us to do our first calculation. The probability of A intersect B is given by PA times PB, that is 0.45 times 0.4, giving us a value of 0.18. Okay. Similarly, A and C are also independent. C are independent. Hence, we have PA intersect C is given by PA times PC. This is 0.45 times 0.3, giving us the value of 0.135. Okay, so let's fill in this information into our Venn diagram. So what information we have at the moment? We have the fact that the intersection between all 3 is 0.1. So we can fill in the value of 0.1 right in the middle over here. Next, we know that A intersect B is 0.18. So this entire region over here is 0.18. So this particular region is given by 0.18 minus 0.1, so which is 0.08. A intersect C is 0.135. So that's this region over here. 0.135 minus 0.1 gives us 0.035. Finally, the probability of A is 0.45. So we can take 0.45 minus 0.08, minus 0.1, and minus 0.035 to give us the value of 0.235, and that goes over here. In part 2, we are also told that B and C are independent. Hence we have P B intersect C is given by PB times PC, which is 0.4 times 0.3, giving us the value of 0.12. So let us fill in more of our Venn diagram. So this region, B intersect C, is 0.12. The intersection of all three is 0.1, giving the region here 0.02. To find the region over here, we have to take the probability of B, which is 0.4. So 0.4 minus 0.08 minus 0.1 minus 0.02. This gives us the value of 0.2. Similarly, we want this region, so we take the probability of C, which is 0.3. So taking 0.3 minus 0.02 minus 0.1 minus 0.035, this gives us the value of 0.165. So this region is 0.165. Finally, the region outside, which is actually what we require in this question. The probability of A prime intersect B prime intersect C prime. So we take 1, the total probability, minus everything we see in our Venn diagram. A slightly faster way is to take the entire A probability of A being 0.45. And then minus these three quantities over here. So we have minus 0.2, minus 0.02, and minus 0.165. This gives us the probability of A prime intersect B prime intersect C prime to be 0.185. And this is our answer. So for part 3 of the question, we are given instead that events B and C are not independent. So this is different from part 2 where we are told that B and C are independent. But we are asked to find the greatest and least possible values of P, A prime intersect B prime intersect C prime. So this is a 4-mark question. The method we will use will be similar to part 2 where we slowly try to fill in the entire Venn diagram. However, unlike part 2 where we can fill in every single part with numbers, we will require a bit of algebra here because we no longer have enough information to fill in everything. This is due to the fact that B and C are no longer independent. So let's take a look again at our Venn diagram from part 2 of the question. So I've actually color-coded my answers from the previous part. The ones in black are only using the information given in the initial paragraph, so these are still valid. The ones in red, however, use the fact that B and C are independent. For part 3 of the question, B and C are no longer independent, so the parts in red in our Venn diagram is no longer valid, so I'll proceed to erase them. To proceed, let's use a bit of algebra. Let us label this region in the middle X. So to fill in this region, we'll take the probability of B, which is 0.4. Taking 0.4 minus 0.08 minus 0.1 minus X gives us the quantity 0.22 minus X. So this region is 0.22 minus X. Similarly, to fill in this region, we take the probability of C, which is 0.3 minus 0.1 minus 0.035 minus X, which gives us the quantity 0.165 minus X. 0.165 minus X. Finally, the region outside. So this region is quite tedious to calculate, but let's go through with it. So we take 1 minus the entire A, which is 0.45, minus these three quantities, minus 0.22 minus X, minus X, minus 0.165 minus X. So with a bit of algebra, be careful with expansions and negative signs, we arrive at the quantity 0.165 plus X. So this region outside, 0.165 plus X. So with the Venn diagram all filled out, we are ready to tackle the question about greatest and least probabilities. Let us focus on X first. What is the least value X can be? Can it be 0? Actually, for this question, it can be. If you look at this, 4 quantities that have X inside them, filling in 0 doesn't arrive at any contradiction. So the least X is actually 0. What about the greatest X? Can X be 1? Turns out that is not valid now. 0.22 minus 1 will give us a negative value. Similarly, this guy will give us a negative value and this guy will give us a value more than 1. So what is the greatest X can be? For this guy to work, it has to be 0.22. But the gain 0.22 won't work because if you plug it inside here, we will end up with another negative value. So the greatest x can actually be is 0.165. Now we are ready to answer the question. Turns out what we want is not x. What we want is the probability of A prime intersect B prime intersect C prime. That's the region outside. The algebra quantity we have is 0.165 plus x. X is in between 0 and 0.165. To get A prime intersect B prime intersect C prime, we simply have to add 0.165 to all three quantities. So we get 0.165 less than equals to x plus 0.165 less than equal to 0.165 plus 0.165 gives us a quantity of 0.33. This solves the questions for us. So the greatest PA prime intersect B prime intersect C prime is 0.33. And the least probability is 0.165. So this slide here summarizes our answers. Also check out our other videos in this series. For a challenge, try to apply the method we have used today for the 2018 Paper 2 Question 7.